You need to hear this if you're a cooking enthusiast. Magnetism and electricity, a powerful duo. Electricity and magnetism are intertwined. A flowing electric current creates a magnetic field. This field surrounds the wire like an invisible force. The strength of this field depends on the amount of current. More current means a stronger magnetic field. Now imagine the current rapidly changing direction. This creates a magnetic field that also rapidly changes direction. We call this alternating current, or AC. Induction heaters use high-frequency AC. This means the current changes direction tens of thousands of times per second. To further intensify the magnetic field, we use an induction coil. This is a wire wound into a spiral shape. The coil concentrates the magnetic field, making it even stronger. If you enjoyed this video, don't forget to like, comment, and subscribe for more fascinating content. The dance of eddy currents generating heat. Imagine placing a pot made of a conductive material like iron or steel near this rapidly changing magnetic field. Something fascinating happens. The magnetic field induces swirling currents within the pot itself. These swirling currents are called eddy currents. They flow in circular patterns confined to the material of the pot. As these eddy currents flow, they encounter resistance from the pot's material. This resistance converts electrical energy into heat, and here's the beauty of induction heating. The heat is generated directly within the pot itself, not transferred from an external source. This makes induction heating incredibly efficient and rapid. Induction cooking, a modern culinary revolution. This principle of induction heating is precisely how induction cooktops work. The cooktop contains the induction coil, generating the fluctuating magnetic field. When you place a compatible pot on the cooktop, eddy currents are induced in the pot's base, generating heat. Compared to traditional gas or electric stoves, induction cooking is remarkably faster. Since heat is generated directly in the cookware, there's minimal heat loss. This also makes induction cooking more energy efficient. Induction cooktops offer precise temperature control. The intensity of the magnetic field, and therefore the heat generated, can be adjusted instantly. This level of control is a boon for delicate cooking tasks. Moreover, induction cooking is inherently safer. The cooktop surface itself doesn't get hot, only the pot heats up. This reduces the risk of burns. Beyond the kitchen induction heating in industry, the applications of induction heating extend far beyond the kitchen. Industries utilize this technology for various processes. Melting metals, for instance, is a common application. Induction furnaces can melt metals with incredible precision, essential for creating high-quality alloys. Heat treating is another vital application. Induction heating allows for controlled heating and cooling of metals, enhancing their strength and durability. This process is crucial in manufacturing automotive parts and tools. From cooking our food to shaping the metals around us, induction heating, rooted in the fundamental principles of electromagnetism, plays a pivotal role in our technological world.